In this screencast, we're going to examine relations and functions, which are a special type of relation, look at the terminology and be able to identify and analyze them, and also to evaluate functions. Okay, functions and relations are very heavy on terminology, so let's get into that now. So the domain is the input that goes into a relation. It is the independent variable. The range, however, is the output. It is what depends on that input. It is very much dependent on what goes into the relation. A relation itself is a set of inputs and outputs, usually expressed as ordered pairs of input and output. The set of inputs consists of the domain, and the set of outputs is the range. A function is a very special type of relation where each element of the domain is paired with exactly one unique element of the range. So let's look at a couple of terms that deal with functions. A special type of function called a one-to-one function, which you'll sometimes refer to as an injection, is where each element of the domain maps to exactly one unique element in the range. If element 1 maps to A, and let's say element 2 maps to B, and element 3, let's say, maps to D, this is a one-to-one function. Each element in the input matches to one unique element in the range. One-to-one function, sometimes referred to as an injection. An onto function, or a surjection, each element in the range is mapped to at least one element of the domain. So let's look at a mapping that is an onto function. So if element 1 maps to A, and let's say element 2 maps to B, and both elements 3 and 4 map to C, then this is an onto function because every element in the range is mapped to by at least one element in the domain. That's an onto function. Let's look at another very important term in mathematics, and that is the idea of something that's discrete versus continuous. Now, something that's discrete, and in the case of relations, we're talking about sets of points. A discrete relation consists of individual, unconnected elements. If you were to graph it, it would appear like a bunch of dots. A continuous relation, however, consists of an infinite number of connected elements. An infinite number of connected elements. So it looks like a smooth curve or line. We'll look at some examples of discrete and some examples of continuous because they are mutually exclusive. Here, this height versus age is a set of discrete. You can notice the points here. Ticket costs. We have individual points. The bottom two here are also discrete because they are sets of individual unconnected ordered pairs. Continuous relations or functions, however, look smooth, whether they're the case of lines like the top three or are curves. These are continuous because they consist of an infinite number of connected points. So discrete and continuous relations and functions are very important to be able to visualize and understand. So we're going to look at two major ways that you can determine if a relation is a function. A function is a very special kind of relation. So analytically is one way. You can analyze the domain and the range from a table, and you're looking to see if a domain element is repeated. So this green box is an example of a function because no element in the domain is repeated. No element in the domain can be more than one thing. Every element matches to one thing. Now, the output could be repeated. Sometimes elements in the domain will map to the same thing. But the key for this to be a function is no element in the input is repeated. This red box is a non-example of a function because you'll notice the element 3 in the domain appears twice. 3 could be 3, or 3 could wind up mapping to 5. That makes it a relation, certainly. It's a relationship, but it is not a function. A function is a very special relationship where we only have one unique set of inputs or domain. A second way, or a visual way, to determine if a relation is a function is known as the vertical line test. Essentially, if I can take an imaginary vertical line and pass it through the relation from left to right and never touch more than one point at a time, it is a function, because what that means is every input is only having one output. So we're going to try that on some examples. So let's take example A here, which looks like some sort of a sinusoidal function. If I run a vertical line through that function at any point from left to right, notice the vertical line, more or less, is only hitting the relation once, meaning that it is a function. In this upward sloping line in B, I'm going to do the vertical line test as well. And notice it's only hitting one point at a time. So every input is only mapping to one output. So example B is a function. C, a parabola. Vertical line test, successful in this upward facing parabola. Each one of my vertical lines is only hitting the function at one place. So C, the parabola, is also this upward facing parabola. Part D, the ellipse, well, I can see it's failing the vertical line test all over the place. Notice this particular vertical line is intersecting the ellipse twice. Not a function. Is an ellipse important? Yes. It's a relation. It's a very special kind of relationship. It is not a function because, for example, this input could be two different outputs. The hyperbola shape in part E is also not a function because it fails the vertical line test. At most any point on the hyperbola, I'm intersecting the hyperbola twice. So all it takes is one failure of the vertical line test for a relationship not to be a function. So the hyperbola in E is not a function. We're going to look at the skill of evaluating functions given the input, finding the output. So let's take a function f of x equals 3 times x squared minus 5x. Now what that means is the input variable is x. All the values that x takes on represent the domain of the function. F of x, when we evaluate this, becomes the output. So you can see that f of x completely depends on the x that we choose. So we'll look at an example. And how we do this is we're going to put that input value into the function and evaluate using the rule of the function. A function is very much like a machine on an assembly line. We have input, something happens, and then something comes out. So let's find f of negative 4. That's how you say it, f of negative 4, because the function depends on the negative 4. Negative 4 is the input. So f of negative 4, I'm going to put that input value of negative 4 into all the x's, all the input variables. So this becomes 3 times negative 4, the quantity squared, minus 5 times negative 4. So everywhere I have an x in the original function, I'm replacing that now with a negative 4. We're going to use the order of operations to completely evaluate this. So moving from left to right, we're going to do our groupings first in our exponents. Negative 4 to the second power is positive 16. So I get 3 times 16. And then 5 times negative 4, I'm doing multiplication now, is positive 20. So we have 3 times 16 plus 20. So f of 4 then becomes 3 times 16, which is 48, plus 20, which is 68. So our answer, f of negative 4, is positive 68. In this screencast, we learned about relations and functions, how to identify their different types, and how to evaluate.